Let's look at another example of a word problem that involves a linear inequality. So the temperature T at the base of a mountain is 90 degrees Fahrenheit, and it drops by 5 degrees Fahrenheit for every 1,000-foot increase in elevation. On what part of the mountain is the temperature cooler than 40 degrees? So in other words, when are we going to need to put a jacket on? Let H be measured in thousands of feet from the base of the mountain. So what this means is if H is 1, we're 1,000 feet from the base of the mountain. If H is 2, we're 2,000 feet from the base of the mountain. All right, I'm going to start this by just setting up a linear function with an equal sign in it, and then we'll modify that to have the inequality in it. So the temperature starts at 90 degrees, and it's going to decrease by 5 degrees for every 1,000-foot increase, or for every time H increases by 1. So that formula, that equation, is going to look like T is equal to 90, our starting temp, and then minus 5H. So that's that 5-degree drop for every 1,000 foot we get from the base of the mountain. We also know that we're interested in when or where the temperature is going to be cooler than 40 degrees. So that would be T is less than 40. Okay, and so we can put these two together into an inequality. So I have 90 minus 5H is less than 40. And then we can go ahead and work on solving that. So what I'm going to do is I really do like to have a positive number in front of my variable. So I am going to add that 5H over to the other side. And so I get that 90 is greater than 40 plus 5H. And so I'll subtract that 40 over to the left-hand side, and that gives me 50 is less than 5H. Right, and then I'm going to divide by 5. So what that tells me is that H is greater than 10. So if I was looking for an interpretation of this, it would be something like above 10,000 feet. Okay, because that would be 10 times that 1,000. So above 10,000 feet, the temp is less than 40 degrees. All right, so that would be kind of an interpretation of what's going on. And then I do want to take one more look at this inequality because I do want to talk about solving these. I know that that is probably not something that's super at the top of everyone's mind. So let's just take another look at this quick. So if instead of adding that 5H to the other side, if I'd subtracted that 90 instead, what I end up with is a negative 5H is less than, let's see, negative 50. Okay, and then to solve this, I would need to divide by negative 5. And so this gives me an H here and a 10 here. But here is the one thing you got to watch out for with inequalities. If you multiply or divide by a negative number, you have to flip that inequality sign over. So it's only when you multiply or divide by a negative number. And so that would turn the sign this way. And so these are the same result. Okay? So no matter which way you go in solving that, you should end up about the same spot. All right, let's look at another example of solving a linear inequality in a word problem. So this problem is about Keith. He has some money saved up in an account and he's going to live off of it this summer. So Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 left at the end of the summer. He plans on spending $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account and still stay above that $200? Let X be the number of weeks Keith withdraws money from his account. Okay. So we're going to set up that inequality. So if A is equal to, and I want you to go ahead and pause the video for just a second and see if you can figure out what that equation is going to look like just as a linear equality. Okay, so he's starting with $500, and he's going to take out $25 per week. So I have 500 minus 25x, and then we know the amount that he wants to have left at the end of the summer needs to be greater than or equal to 200. So we can put this together, and we get 500 is greater than or equal, I'm sorry, 500 minus 25x, better get that whole part in there, is greater than or equal to 200. All right, so I would love for you to go ahead and pause the video, see if you can solve that on your own, and then we'll come back and take a look. All right, so hopefully you had a chance to go ahead and solve that. Let's see. Again, I really do prefer to have that positive number, and that's just a personal preference. If you are great with handling those negative numbers, feel free to solve it, leaving that on this side. But I really do like having a positive number in front of my variable. So I have 500 is greater than or equal to 200 plus 25x. I'll subtract that 200 over, so it gives me 300 is greater than or equal to 25x. I'll divide both of those sides by 25, and that tells me that x is less than or equal to 12. Okay, so what that means is Keith has enough money for 12 weeks or less this summer in order to end up starting the fall semester with $200 in his account. All right. If you're still struggling with some of these inequalities and solving them, there are some optional videos that you can watch that go with the next page.